Hello students, in our last lecture we studied about the international system of units. Now in this lecture we will study about different methods for the measurement of length. Now there are two basically methods by which we can measure the length. One is the direct method and the other is indirect method. Now first we will discuss about the direct method. In this method we directly use some instrument for measuring the length or a distance. We generally use a meter scale to measure the length, and with the help of this meter scale we can measure minimum length of about 10 raised to minus 3 meter. Now this 10 raised to minus 3 meter means it is 1 mm, 1 millimeter, and maximum we can measure about 10 raised to 2 meter. Here a photo of a typical wooden meter scale is given. Students, here a 0 mark will be there, and from 0 to 1 this much distance is 1 centimeter, that you all know, and if we'll move further then it will be 2 centimeter, 3 centimeter, and up to there will be 100 centimeter, and 100 centimeter means that is equal to 1 meter. So with the help of this scale we can measure 1 meter, 2 meter, 3 meter for a full scale. But again, if we consider only 2 marks, you can see here, if I consider from this particular line to this line, then this much distance is 1/10 of a centimeter, and 1/10 of a centimeter is equal to 0.1 centimeter, and 0.1 centimeter means it is 1 millimeter. So with the help of this meter scale, the minimum length which can be measured accurately is 1 mm. Now students, you can see one another kind of a meter scale. The only difference between that previous wooden meter scale and this meter scale is that this type of meter scale are flexible and one can easily fold it, while other scales made up of metals, plastic, wood, etc. cannot be folded. Rest of the things are same. Next is about Vernier calipers. Even this instrument measures the length. Now students, why we need Vernier calipers? Because as I told earlier that with the help of meter scale we can measure minimum length of about 10 raised to minus 3 meter, that is 1 mm only. But if smaller than this measurement is required to be measured, then some other instrument is needed. And here vernier calipers can even measure 10 times smaller than the main scale. So here you can see the power of 10 is minus 4. So if we'll compare these two, we can say that this measurement is 10 times smaller than this measurement. Students, you can see here this instrument which is known as vernier calipers. You will study about this vernier calipers in more detail in your practicals. Even there are 2 or 3 practicals in which there is a use of vernier calipers. You can see here there are different parts of vernier calipers. Here this is a main scale, and this scale which slides over the main scale is a vernier scale. You can see in this picture that there is a main scale in the upper part, 0 of the main scale, number 1 of the main scale. This distance is 1 centimeter as usual, we know, and this scale is a vernier scale. This is main scale, and the instrument is called the vernier calipers. Students, you can see here a digital vernier calipers. The earlier vernier calipers which I have shown you were analog vernier calipers. With the help of that vernier calipers, we can measure the length of the instrument with more accuracy, but it requires proper technique, proper method, proper care. But with the help of this digital vernier calipers, we can easily measure the length of a given object with more accuracy, with less efforts. Next instrument is called screw gauge, as well as there is a spherometer. This type of instrument can measure accurately up to 10 raised to minus 5 meter, means even 10 times smaller than vernier calipers. You can see here that for vernier calipers it is 10 raised to minus 4, and for this screw gauge or spherometer it is 10 raised to minus 5 meter. Here you can see an image of a screw gauge. Now here the thing which is to be measured is kept here, and with the help of this screw you can move this left or right. Here there is a main scale, and this circular scale can rotate over a main scale. In most screw gauge there are 100 divisions on this circular scale, and when one rotation is completed, 1 mm is moved either towards left or towards right. You can see here one more image of a screw gauge. Here it is clearly shown that there are 100 divisions on this circular scale. This is main scale. Here it is written. This is a gap between which the object is placed, whose dimensions is to be measured. This instrument is called a spherometer. Here this vertical scale is a main scale, and this circular disc, which can be rotated, on which there are 100 divisions. So here also this instrument is similar to that of a screw gauge, but with the help of this instrument we can measure the radius of a spherical surface. You can see here a watch glass is placed, and for this watch glass we can measure its radius of curvature. Students, while using this instrument, a care is to be taken so that we can get a precise and accurate measurement. Now about the least count of these instruments. Least count means the minimum measurement which can be done with the help of these instruments. So we have already studied that for a meter scale, the least count, that is minimum measurement which can be done, is 0.1 centimeter. Then Vernier calipers, which can measure even 10 times smaller than meter scale, means 0.1 divided by 10 will be equal to 0.01 centimeter. And then about screw gauge, which can measure even 10 times smaller than vernier scale. So again, if we'll divide this 0.01 by 10, we will get 0.001 centimeter. Now, indirect methods. In indirect methods, we don't use any instrument directly to measure the dimensions of an object. Dimension means length, breadth, height, radius, etc. This type of indirect methods are generally used to measure very large or very small distances. Very large distance means the distance between the two planets, the distance between the earth and the sun, etc. And very small measurement or very small distance means the length or the diameter of a molecule or thickness of a page or a metallic foil, etc. Now, to measure the large distances, the method used is a parallax method. Now, with the help of this method, we can measure the distance of sun or a star or a planet or any other celestial objects from the earth. As shown in figure, Suppose we want to measure the distance of sun from the earth. So in this we have to take or choose 2 points on the earth. We have to observe the sun from each 2 points, from A and from B, and when these two line of observations meet at this point, that is at the sun, they make an angle theta. This angle theta is very much small, even it is less than 1 degree or even less than 100 times of 1 degree, and this angle is called the parallax angle. And according to the formula of this parallax method, the angle theta is equal to B upon D, means the angle is equal to length of arc upon radius, because this line can be considered as an arc, and so angle theta is length of arc upon the radius. This distance is nothing but it is like a radius. This is formula for the plane angle, which you have studied in the first lecture. So applying that only here, symbolically we can write this as theta is equal to, this is opposite whose symbol is B, so it is B here, upon this distance is capital D, so it is here. So theta is equal to small b upon D. And remember, the unit of angle in SI system is radian. So after putting the values of this B and D, we will get the answer in terms of radian. Generally, we use degree for the angle, but here we are not going to use the degree, because degree is not the SI system. In SI system, the unit is radian. Now out of these three physical quantities, that is theta, B and capital D, if the values of any two physical quantities are given, then we can find the third physical quantity with its value and unit. Now here, if we want to find the distance of the sun from the earth, then simply we have to make this D subject in this equation. So if we'll bring this D here, then we have to bring this theta here, so we can get the formula of the distance. So this was about the measuring large distances. Here these 2 points A and B are the diametrically opposite points of the earth. Now if we want to measure the diameter of the sun or diameter of any planet or a star from the earth, then we use the next method, which is shown here. Now from the figure you can see that this is a point on the earth and this is any celestial object. Consider that this is a moon and we need to find the diameter of the moon from the earth. In this method, from this point we have to observe first this point of this moon, and then from the same point, that is on the earth, we will observe the next point of the moon. So these 2 points which were observed from the earth are the diametrically opposite points of this moon. Now here this angle made at this point due to these 2 line of observations is denoted by alpha, and this angle alpha is very small. And now applying once again the formula similar to that of that parallax angle, or we can say about the plane angle which we have studied in our first lecture, that angle alpha is equal to small d upon capital D. So here you can see this formula, alpha is equal to small d upon capital D. Once again this alpha is angle, so in SI system of units its unit is radian. Now here we want to find the diameter of the moon, so we will make subject small d. So if we make this subject small d, we have to bring this d here. So finally we will get small d is equal to alpha into capital D. This method is called the method of angular diameter, and this alpha is called the angular diameter. Now if the diameter of the moon is known to us, then we can find the radius of the moon, which is half of the diameter. And if the radius is known to us, then we can find the volume of the moon, or we can say the size of the moon. As moon is a spherical in shape, its volume can be obtained by V is equal to 4 by 3 pi r cube. So in this way we can find diameter or the volume of any celestial objects. Now to measure very small distance, example the size of a molecule. So if the dimensions are very much small, then we cannot use Vernier calipers, micrometer screw or any other instrument. For that, again an indirect method is required. Here it is given that the size of a molecule is of the order of 10 raised to minus 8 meter to 10 raised to minus 10 meter. Even simple microscope or an optical microscope are unable to resolve this type of small objects like molecules or atoms. Now remember that the optical microscope uses light for its visibility, and the wavelength of light is of the order of 4000 angstrom to 7000 angstrom, whereas the size of the molecule is even smaller than the wavelength of light, and so optical microscope cannot resolve these small molecules or atoms. So for this, electron microscope can be used. Now see the word electron. This type of microscope uses electron beam for resolving such type of small particles. Electron microscope can resolve the particles of the size of about zero point 0.6 angstrom. So here this 0.6 angstrom, which is quite smaller than the dimensions of atoms or molecules, and as it is smaller than the dimensions of the atoms or the molecules, this microscope can resolve these particles in a material. Here in this figure you can see an electron microscope. Here this is an electron beam which is emerging out from this electron gun. This is an electron gun from which these electron beams are moving, and they used to fall on the material which is to be examined or which is to be studied. Here in this image you can see the distance between the atoms of H2O molecule. So with the help of this electron microscope we can estimate the approximate distance between the atoms of a molecule. In this electron microscope, the beam of electron which emerges out from an electron gun is considered to be having a wave nature. Actually electrons, they are particles, but here they behave as a wave. Now if the particles are still smaller than the atoms or a molecule, then we have to use the tunneling microscope. Sometimes it is known as scanning tunneling microscope. In standard 10th you have studied about the nanotechnology. In nanotechnology we know that the particles are very much small, even smaller than the atoms or the molecules. So for the study of such type of materials consisting of these nanoparticles, this type of microscopes are used. This type of microscope have a very high resolving power. Here in this image you can see a scanning tunneling microscope which has a very high resolving power. These are used for many scientific purposes. In this image also you can see a scanning tunneling microscope which resolves atoms or molecules with very high resolution. The resolution with the help of this microscope is very much better than the electron microscope, and so even the defects in a material can be detected. Here you can see the image taken by this scanning tunneling microscope of a very small particles. Even this image you can see which is taken by such microscopes. One more method of measuring the size of a molecule is the method of monomolecular layer. In this method, a substance is taken whose size of molecules is to be measured. Now, this substance is made thinner and thinner till its thickness becomes that of the size of the molecule, and after that its thickness is measured with the help of some technique or some instrument. You can see here a monomolecular layer of some substance.